Gonna work on the wiring again on that Oliver. The last time I started it, when I was messing with the cooling system flush and fill, I noticed the battery was getting kind of low. It was cranking a little slow. So I really want to straighten out that alternator wiring and see if that alternator is working, so that next time I'm using it, it'll charge up the battery some. Today we had an unusually warm day here for beginning of December. It was high in the low 50s. Sun shining now. Temperature dropped quite a bit this afternoon. Front must have moved in. But make a long story short, I'm going to see whether or not it cold starts today. Alright, so what I'm going to do is let's see whether or not we can get it to start without using any starting aid or starting fluid. And I use the preheater. Try it again. What's the problem with the electric preheater is that's sapping off some power from the battery. That battery sounds way too low. Alright, I'm getting some smoke out of the stack though. I'm going to see whether or not I can catch it to start with a little starter fluid, so I can drive it over close to the house and throw the battery on the charger. A little blast of starting fluid and started right up. Only made a couple of spins and cranked right up, so that's good. So now I can drive it over to the house, put the battery on the charger, or work on the wiring or whatever. Alright, I cleaned up a lot of the gunk on the back of this alternator for a couple of reasons. One reason was I wanted to make sure that I could see what the terminals were labeled, but also I also wanted to clean out these holes in the back because they're actually involved in keeping the alternator cool, specifically the regulator circuit and the diode pack, which if it's still good in this alternator, I'd like to not burn it out just because I'm not letting it get ventilated. So on the back here, it's going to kind of hard to see, but let's see if I can get this light to work. On the back here, you can see there's a terminal on the left where that plug goes in, marked R, and there's a terminal on the right marked F. Now typically you'll see these won't be marked with letters, they'll be marked with numbers 1 and 2, and usually your 2 is on the right. I'm going by memory here, but I'm pretty sure that's correct. Now 2, you'll notice that on this alternator there's a wire on number 2, or the F terminal. It goes right over to the battery terminal, and so it's tied to the battery terminal. And then you've got the wire on the left, number 1, or the R, which is your white wire, is going to my wiring harness. So this is technically a 3-wire alternator that's converted to a 2-wire application. And the way that that's being done is that red wire is used for voltage sensing. And what I'm going to do is I'm going to reroute that wire back up to under the dash panel. And I'll explain a little bit more about that later. And then, so what you don't need to do that to make this alternator work. But you get an issue with voltage drop, or you can get an issue with voltage drop when you're running accessories. And so I'm just gonna, I've got the wiring here. You can see I've got a wire right there that's cut off, that's unused. So I might as well put it to good use. So I'm going to disconnect that from the battery terminal. I'm going to strip it and put a connector on there and route that up to under the dashboard, and I'll explain where that goes later. To make this alternator actually put out voltage the way it is right now, if it's a working alternator, all you need to do is make sure this white wire goes up under the dash to the key switch and has 12 volts on it when it's in the ignition on position. And then you'll get output out of this alternator by doing that. I want this thing to make power available immediately. I don't want to have to rev up the engine to make that happen. So I want it to I believe the term is self-excite, and so I'm going to do that by rigging up an what they call an idiot light or a charge indicator light up on the dash, and we may have to add a resistance to that wire, which can be done either with an actual wire called resistor wire, which is a special type of wire that actually has a certain amount of resistance to it, or you can use regular wire and then put a properly sized wire wound resistor in series with it. So haven't decided yet which method I'm going to use there, but for right now what I want to do is I want to take that wire off the terminal there and splice it to this wire right here. Now I've noticed that of the 3 wires I've got here, I've got 2 heavier gauge wires and 1 light gauge wire. So my light gauge wire is the one I have available for this terminal to now go to, but this wire is a little heavier. The white wire is the light gauge wire. So I'd rather have the white wire using the light gauge wire and the red wire using this heavier one. So I'm actually going to undo this splice right here that somebody did and switch these around. Hey everybody, it got too dark the other day and I didn't have everything I wanted to work on this really, so I decided to quit, and now I'm starting fresh this morning. It's a little colder this morning, but I was able to pick up some stuff I wanted to get. I decided that I don't like how light the gauge of this wire is right here for the wire that's going to run from the battery terminal on the alternator over to the ammeter. I want a heavier gauge wire. What gauge wire do I want? Well, basically I want a gauge of wire heavy enough to carry enough current to supply everything that I'm going to run for auxiliary items, accessories, and battery charging on this thing. So basically your whole system. So like in a car, we've got a whole lot more going on with electronics and that. You could have a pretty heavy gauge wire. You might even see a 2 gauge wire on here. That being said, I don't need anything that heavy, but I still want something heavier than what was on here. Which is, you know, this looks like it's probably, that looks like it might be 12 gauge wire right there. So we could do better than that. I had some leftover copper wire. This is actually from a big Romex cable, multi-conductor cable that I had a scrap of it left over, and I stripped off the outer sheathing, and that gave me 3 lengths of some nice heavy, what looks to be about number 6 gauge wire, and that's going to give me enough current carrying capability for my project here, because basically all I'm running on this is I'm running some meters, you know, a couple of indicator meters. Those don't draw much current. Got a horn. We're gonna have lights. We got 2 headlights up there on the front. We get a flasher that's broken over there that if I decide to replace that, I want to replace that at some point maybe. There was another one on this side that's broken off. And then also I might want to remotely mount a spot flood on the back here. That's kind of nice to have if you actually, it's getting late and you're trying to finish up a job and you want some light on where you're digging. Probably never going to really need it, but if down the road I wanted to add that, I could. Heck, even if I wanted to put a stereo on this thing, not that I'd hear it over the engine, but point is, we could do better than what was on here. So, I'm going to use this wire here, and then I could use regular crimp connectors on there, but I don't like crimp connectors. So, in the spirit of overkill, I picked up this style connector. These are from my local Napa. Got what do you got? Somewhere in here I got another package of them. One of those in there they sell as singles. I just put it in here so it wouldn't get lost. So the one with the larger hole there is going to go in the alternator. The one with the smaller hole is going to go on the ammeter. Actually, scratch that. I'll get to where that's going in a second. These are solder type connectors. They give you a much better connection, but you pay a premium for these. These are a few dollars a piece for these. I think that the 2-pack was like $8 or $9. And it's because it's solid copper, and copper's at a premium right now. Not much you can do to get around that. The other thing I did was I decided that I didn't want to run that wire directly to the ammeter like it had been running, without any kind of fusing in there. So I wanted to make that a fusible link in some way, and the best way I figured to do that was for about $7. I got a circuit breaker. This is a common type you find mounted on the firewall or on the dash fender inside of an automobile, and they have several different ratings, and I decided on a 30 amp because I wanted something not that doesn't coincide with how much amperage that alternator will supply. It's much higher than 30, but what the wiring can handle and what I anticipate for a load. So basically I just want something in there to protect this, so that if I get a short in the dash area or a short in the alternator, I won't have the battery current trying to run through this to the shorted alternator, or the alternator flowing current through a short in the dash and overheating this wire and melting it. Now, in an automobile, you could have a fire. With this diesel and a solid steel dashboard, there isn't really much to burn other than the wiring itself. But I mean, even that, who wants to go through the trouble of rewiring the whole thing again if you don't have to, just because you had some little stupid short up there cause a complete meltdown of your wiring? I mean, there's actually an indication on here of some wiring that got overheated already, or arced out, something like that. So that being said, that's why we're going to mount this. This is a circuit breaker. It self-resets. So basically, when it gets too hot from passing over 30 amps of current, it will open. And then after the short is removed and it cools down, it will automatically reset itself. So that's for $7 and the cost of a couple other more of these spade connectors. That's cheap insurance, in my opinion, to keep things healthy as far as the wiring goes. So also picked up a light switch, same style that was in there originally. Well, I should say same style that was in there when I got the machine. Probably not the original style, because it's a 2-position switch, so I'm not sure what the deal is there. But I'm thinking I'll probably wire it so that position 1 eventually will be the flashers on the back there, and position 2 will be the flashers stay on and the headlights come on. I'm thinking that's a good combination, so that's probably how we'll wire it. That was $10, and it's the same style. It's got the fuse right on the back of it, which is nice. So that was a good investment. I was going to get the one where it was just one single position, just to run the headlights, and then I remembered that there were some kind of flashes on here. And the funny thing was, the single position switch had a little chrome knob on it that was plastic, chromed plastic, which is just as cheesy as the plastic knob that's on here. It's $15. You pay more money, and it didn't have a fuse on it. It was just a straight switch. So then I'd have to add another fuse, so another fuse holder. So this way I went with this. So we're going to start putting this all together and do a little bit more explanation about how the wiring's going to work on this thing.